So hello and welcome to the next episode in Hour of Code. Today's topic is reflection in .NET, what reflection is and what it does. And sort of we'll probably get into what we can do with reflection after that. So in short, reflection is code related to code, I suppose is one way. Like it's a way for you can ask your code to look at the code, like some other either some other piece of code that you have or the code of itself, and it can tell you things like about classes or methods or stuff like that. And that's basically it. That's what reflection is. And then because of that, you can get access, like you can use reflection to do things that you're not really supposed to do. Like you can gain access to private properties, so you can change them. You can instantiate classes that you don't know the name of at compile time and stuff like that. So let's kind of just get started, and I'll show you how it works. So first of all, we're gonna replace this little line of code here. We don't need that. What we're gonna do is we are going to just reflect over all the classes inside this assembly. That's going to be the first thing we do. So then the obvious question is, what is an assembly? The easiest way to think of it is that each thing you have over here in your project overview, I can't zoom in on this unfortunately, each of these is an assembly. It's a project, and when you compile it, it becomes a DLL file, and we tend to refer to them as assemblies because that's their in-code name. So what I'm going to do is I'm going to find all classes defined inside this assembly, and then I'm going to print their name to the console so that we can get a list of everything that exists. Currently, we only have program, so it should be only program, but that's a start. So we'll just write assembly here and press Control dot, and it should tell us that we need to use system.reflection. And that's the namespace where 99% of everything related to reflection lives in. So now we have this assembly type. So now we can do assembly. We can get executing assembly. That's like get this assembly kind of, but it means the one that's currently running. So it's the one that started the program. And then here we can do get types. For example, this will give us all the types declared inside this assembly. So we'll just do var types equals this. Now we'll just do a quick for each. So for each item in types, and we'll do console write line item dot. We'll do item dot full name. So now if we run this, it'll just tell us hour of code dot reflect dot program, because program is in hour of code dot reflect. So that makes sense. So now if I create a new class here, I'll just add a new class, and I'll my sample class, and it's just going to be a class, nothing else. If I run this code again, we will now see that it shows both program and my sample class. So using reflection, so this is reflection, right? This is using the system.reflection code. We can look at this assembly and we can inspect the types. Now this itself is not super useful, of course, right? We printed the name, but what types is here, it's a type array. It's a type array. And anything that is a type, you can do lots of things with it. For example, we accessed full name here, but what else can we do? What else can we do with an item, with a type? Well, we have the name, we have the assembly, we have some boolean that tells if it's a class or not, because structs are also types, enums are also types, lots of things are types, not necessarily a class. So it can be sometimes nice to know that. We can check if it contains generic parameters, like is it a class that has a generic type? We can look at that. We can find all interfaces that this class or type inherits. We can find members. So members is usually fields and properties and stuff like that. I think you can use this to get like all kinds of crazy things. And you can specify what type of member you want or what type of binding they have and stuff, and you can make a filter and stuff like that. And you also look at all. There's so many things you can do here. Like there's get constructor, which will try to get you a constructor that matches the thing you pass in, or get constructors, which will return all the public constructors. It will give you a list of all the constructors, and then you can pick the one you want to use and use it. Because the most common thing you would use reflection for is probably instantiating anonymous types. And what I mean with that is, like, for example, anonymous types is a bad word for it because that's another thing. But like types that you don't know at compile time, like for example, reflection is very commonly used within things like ASP.NET, Mediator, Automapper. All these things use it a lot. It's used in the test frameworks as well. And that's because like code that needs to look at other code will probably need to use reflection to do anything useful. In the case of ASP.NET, a very common thing is, where if you look at program. In fact, let's just open up some sample ASP.NET program I have. So I'll just scroll down here until I find web application 2. Perfect. I'll do that. It's loading on my other screen. I'll just pull it over as soon as it's finished loading. Here we go. So for example, it's loading, so we'll get syntax highlighting soon. But this is obviously a controller, right? We have test controller and it inherits controller base. We have an API controller attribute. We have a route attribute. We have this HTTP GET attribute on this method here. But if we look at the references, this is taking forever, obviously, for some reason. So we do find all references on test controller. There are no references. There are no references to test controller. So, I mean, we never say, var x equals new test controller. So how does this controller work? Well, because ASP.NET itself, in the startup file here, we do this, services.add controllers. So what does add controllers do? Like, how does that know about my controller, right? Notice how it's not generic, right? I'm not specifying a type like here or here, right? So how does it add all the controllers? Well, that has to do with this attribute. So let's go back to our sample code and try to build something like that, right? We want to get a list here. So instead of getting all the types, we should say get all types that has a certain attribute. That's what we want to do. That's what we really want to do. And then we're just going to print them, just like we did before. So we'll have to make an attribute. That's fine. So we'll make a few classes here, right? We have my sample class. That's fine. So we'll make a new class here. We'll say class my controller. And then we'll make class my other controller. And we'll just flag these with we'll flag them with an attribute called hour of code. So if they have hour of code, we want to get them. Now, hour of code is red because it's like, hey, I don't know what this is. That's not an attribute class. So we're going to make one. I'll put it at the top, actually, like this. So this is my little class here that inherits from attribute, from system.attribute. And we obviously should use this. This is like, this attribute itself tells you how this attribute can be used. Very confusing and lovely. But I'll just make an attribute. Like, it doesn't need to have a body or anything, because this is just like it's called like a tracking or a tag attribute. If you put it on something, that's all you need to do. You don't need to specify like properties or settings for it. It's just like either you have it or you don't. In this case, my two controller classes have it, and sample class does not. So if we go back here, if we run this now, we'll get all the types, right? Remember, we get the attribute itself, we get the sample class, we get controller, my other controller, and we get program. So now we want to filter these a little bit. So we're going to do get. So right, there's some get custom attributes. So getting a type that's decorated is so common that there are like helper ways to do that. Retrieve a custom attribute of a specified type that is applied to a specific assembly. Is the get custom attributes? Maybe get all the custom attributes as assembly. No, it's not that. So it's get types. We still need to do get types, but then we can do .where, and we will include link for that. And this is getting very long, so we'll start breaking it down a little bit, right? We can do where t, and then t dot, and we can like has. I'm pretty sure there's a method for this. Yes. Perhaps actually, doing this with a where will be hard to read and confusing. So let's just do it like this. So we'll say if item dot custom attributes. We'll do get custom attribute of type, and I will specify my hour of code attribute. So if that is not null, oops, I need to fix formatting. Oh, right. It's also a namespace. We need to rename that a little bit so to make that work. That's fine. We'll go in here. Actually, if we specify the full name, it should be fine. So we'll do that. Hour of code attribute. So you know how it's called hour of code attribute here with the word attribute, but it's not here, and that's sort of inferred. Like whenever you write anything with attribute tags, it adds the word attribute automatically, and every attribute should have an attribute suffix to it. I'll just clean this up as well. So there we say if it is null, we say if it is null instead of not null, we will continue. So we'll just skip it, right? So now if we run this, we'll see that we get only my controller and my other controller. That was really all we had to do. So we could have added that as a .where here. That would be fine. But this is slightly easier to read, I think. So this is essentially what add controller does, right? When you do add controller, it just does assembly, get executing assembly, get all types, and then it checks that, hey, everything that has my API controller or the other control, like there's a few different controller attributes. It checks that you have one of them, and then you get added to, like, then you get registered as a scoped service in the service provider. That's what add controllers does. So obviously this is like reflection itself is mostly useful when you're dealing with multiple projects. It's not super useful to reflect over your own code. There are cases where you want to do it. There are definitely cases where you want to do it, but most of the time you will probably be having like you'll either reflect over a library, or more likely you will call code that lives in that's written in a library that needs to have access to your runtime. So it will use reflection to look at the types in your using library. A mapping library is a very good example of that, where it will look at the properties. Like when you say, like, add mapping for from type X to type Y, it will look at the properties of type X and try to create a mapping from that to type Y. So it will look at both type X and type Y using reflection to look at the members. So yeah, let's add some things here, right? Let's add a property here. So we'll just say my property, that's fine, and we'll add a method here. Perfect. So now we have a property and a method, and now we want to reflect over them. So what we can do here, I'll just close some of these down, is that instead of just typing out the type, we'll do that too. But then here, after we've printed out the type, we're now gonna reflect even more, right? We're gonna do item.get members. Yeah, so we'll do Is there a member? No, there's yeah. So we'll do get members, right? Yeah, there's also find members. Oh, yeah, we'll do get members. So we'll do get members. We'll say var members equals item get members, and then we'll just do the same. So we'll loop over member in members, and we'll do cw member dot name. And we will add in a little bit of a I'll just add a tab so we can easily. So now we see it looks like this. So when we reflected over everything in all the members in each of these types, you can see that my controller, for example, right, we had a property. But what a property actually is behind the scenes, right, it's a get method and a set method and the property itself. So this is the backing field, and these are the accessors. Get type is a method that comes from object, just like toString and equals and get hash code. And since we also have a default constructor. Even if you don't specify a constructor, a class will by default have an empty constructor, right? And that's what we're seeing here. So we're seeing all the methods and the fields declared. But maybe just printing the name is not very fun. Like it doesn't really give us enough information. So we should try to print some more stuff. So we'll do member dot. We should be able to get like access. Gets the class that declares this member. Nope. Not really finding what I was looking for here. I would expect you to be able to find. I mean, there's member type, so we can see what it is. That's good. Let's do that. So we'll include member type just to see what we got. And now we can see, look, yeah, so these are methods. This is a constructor and this is a property. All right, that's slightly better. Is there anything else we can find that's really interesting? We can look at the custom attributes, which we don't really want to. No, that's pretty much what we can just look at like that. What's metadata token? All right, no, that's not interesting. So this gives us information like this using. So you see that like so item is a type, and when we call get members, we get like this list of member info. There is also one called method info as well for specifically methods, which you need to invoke methods and stuff like that. So yeah, we've done now. So yeah, now I've kind of shown you like what we can do, right? We can look at types and get information about them. But let's actually move on to something slightly more interesting. So I have some code here called external code. And what this is that someone on Reddit actually asked me a few months ago, like, I want to be able to load plugins into my program and execute them. Like, how would I do that? How would I let my users write their own .NET code and somehow, make that run inside my application? For example, let's say you're making a game, right, and you want to let your users make a mod for it or something like that. And that uses reflection. So I'm going to show you how that works. So we have three things here. We have runner, which is like, this sort of represents the game. This would represent the host. This is the program that will try to load external libraries. Then we have lib, which is a shared dependency between, so runner will require lib and first plugin will require lib, because we need to have like a shared contract. I can't just randomly load things and try to run them, right? For them to be recognized as valid plugins for my code, I need them to implement this interface. So that's what this interface is. It's just a public interface with a public method. That's it. Nothing else. And here is one of my plugin. Like here's the example plugin, right? So this is my first plugin. I have first plugin 1. It inherits from external code, and it just implements the run method, right? It just prints, gets some data in, we don't know where from, and we print it. Runner is where all the interesting code is. So first we'll just run through this quickly what this is, right? So first we just say what we're doing. We say checking for external assemblies to load. Then we do this thing called get external code classes, and we pass in a path. So this is a method I've written, so we'll go look at what that does. But then we say found this many external plugin types. So found external length external plugin types. If there was not 0, then we try to read in data, and then we pass that we save that data into a file, into a string variable. Then we'll loop over all the external types that we got from this method up here, and we try to create them using activator.createInstance. So this basically just calls a parameterless constructor of that type. By default, you can specify parameters too, but parametered constructors are hard, especially if you don't know what types what kind of constructors they will require. So most of the time you just say, hey, make it be parameterless. And then we also, since this returns an object, we will cast it to iExternal code, so that we can actually call things on it. And then we have a little bit of a null check here, and then we say run, and this is my data. So very, very simple. So now let's go over what this method does, because this method actually does a few things, right? It makes a list called proper external classes, and then it looks at potential assemblies. So once again, we have to go look down here. What is potential assemblies? Well, we pass in a path, right? And then if that path doesn't exist, we write that, hey, no plugin directory exists, and we return nothing. Yield break will stop the loop, because there was no plugin directory, so we can't find any plugins. Otherwise, we literally just do enumerate files, and everything that has that ends with .dll in that folder, we will yield. So that gets added to this list. So when we loop over this here, this is just so for each potential assembly in potential assemblies, we will try to load it using assembly load file. And we pass in the path. So we will load that. That basically takes that DLL file and loads it into our application's memory so that we can access it. Then we do assembly.getExportedTypes. So this is kind of like the .getTypes method I used before, but instead I say getExportedTypes, which means look only at public things. Look only at things that are visible outside the assembly, meaning things that I could look at. And then I also say that where T is assignable to external code. So this means you need to implement this interface, and also I also added this that you can't be abstract. So you must not be abstract, because otherwise we can't instantiate it with this one. This won't work if it's abstract. And then I just collect them to an array. If there are more than 0, I loop over them and add them to my proper list. And then at the end, I return my list. And if there are any errors, I just print the error. And then, and then we will loop. That's basically what we do. So now, how this and what this actually looks like, if we look at this in here, I'll open it in a file explorer so you can look at it. Looks like any other .NET project, except in the bin folder in here, I have a folder called plugins, and in here is the DLL file from here. So this is from here. I've manually copied it in. So when I just move that in here. So when we run the runner, it will say, checking for external assemblies to load. I can zoom in here. Found one external plugin type, enter data, hello. And then it says, hello from an externally provided DLL. Here is your data. Hello. So that was like a way to load external things. So as an example, I could now make a new project here, right? Actually, you know what? To really prove how weird this is, let's just make it in a new Visual Studio window, right? We'll close the solution, and I'll create a new project, and I'll just make it loading class library. and I'll say hour of code dot plugin. All right, I'll make my own plugin here. Perfect. And we're going to add a project reference, except we need to browse for it. And this might be a bit weird because we need to go to repos. I think it is external code, right? Because we need to have a dependency on this thing, on the library. So we can actually find this here, like that. Since normally I would have a project reference, but like, for example, if this was published, like if I were a game maker that wanted to let people make mods, I would just have this DLL somewhere on my website or bundled with the game, and I would say that, hey, if you want, just add a reference to this DLL file if you want to make a game. So now we're just gonna do external code, I think we called it. Yep. And we need to do this, so I'll just implement interface where I say we ignore the data, right? We don't care what they say. We just want to print. Hour of code was here. Yay! So we'll build this, and I will open this. I'll go into my bin folder. I will take my plugin. I will copy it. I will go back here. I'll just put it in here, right? And now we will. Oops. I should run this project. And now we found 2 external plugin types. And if we type in hello ASD, we see hello from an externally provided DLL. Here's your data. And also, hour of code was here using reflection. So without knowing anything about the runner, only having this interface specified by a shared library, we could make a plugin. Yeah, and so when using reflection, like, the sky is the limit. You can do so many things using this because you can look at types. There's one more example I want to do. I want to show you in a project you might or might not have heard of called BusyList. BusyList is one of the shared projects we do here on the Discord. And in this, I have made a spike here for this, which actually uses a dispatcher. So I'm going to actually let me first show you how it looks in the master, so that you can see what problem we're trying to solve, and then I will show you how we solve it. So BusyList uses the command pattern. So we have this we have these objects called commands. They are records, but they're essentially just like specialized classes. But the important thing here is to see that read command inherits from command, and next command inherits from command. Everything inherits from command, and command is just an empty record. This means that we can, like, these kind of encapsulate a request, a demand, a command, like something we want to do, an intent to do. And then all the things that actually do this happens in the handlers. So for example, here is add handler, right? And this is the handler for add command. That's how we say this. We say add handler is an iHandler that handles this type. And what iHandler looks like, it just looks like this. So it's an interface. We take in a type parameter here called tCommand, and we say that tCommand must be a command. And we also then have a run method that takes in a tCommand. So these are generics, by the way, if you haven't looked at them. We have talked about generics before, and they're a very important concept. It's compile time reflection. It's not reflection. It just it generates code behind the scenes, but it lets us not know what type at compile time, at coding, at design time. So that's really cool. And how we use this. So how we use this, if we go to program, we have down here, we have handle command. So you pass in a command that you want handled, right? And what we do here is we switch it. We say switch command, and we say, hey, is it an add command? Then do this. Then we say, get the handler for add command and run it. And we do the same thing here and here and here and here, and this bothers me. As a programmer, I'm like, wait, these 5 lines are identical. And now if I add a new handler and a new command, I have to remember to go in here and add this to them, otherwise we will hit this error. Surely there must be a better way to do this, right? Surely there must be a better way to solve this problem. And the answer is yes, of course there is. We also have to register them, right? Whoops. So now we will load the dispatcher branch, and you'll see that handle command suddenly looks a lot better. Handle command now literally just uses the passed-in provider to make a command dispatcher. And then we say dispatcher.handle command. And if we look at the command dispatcher, it looks like this. It has a handle T, where T is a command. And when you pass that in, what we do is we say handler type equals type of iHandler, and then this weird thing here. This means like we want the generic version, but we don't want, we mean the generic type. We mean iHandler, the generic version, but we don't know what generic argument yet. And then we call .make generic type, and we pass in command get type. So we get the type of this thing here that you passed in, because that's a type. So we pass in a type to this function, and that will create another type that is the iHandler of that type. I know this is really confusing, but essentially, if the command here is an add command, then the handler type will be iHandler of add command. That will be the result. But we're doing that at runtime, not design or compile time. That's the important thing. So this is very much reflection. Make generic type is reflection. And then what we now can do is that we can take this type here and we can pass it into service provider for get service, and we can try to cast it as iHandler of T, because we know it actually is an iHandler of T, right? If the handler is null, we throw an unregistered command exception, just like we did before. And then finally, if it was not null, right, we're going to get to this point where we just call handler.run. And we pass in command. So these lines of code now replace that. So now, in order to make this work, all you need to do, if you go to program, you still need to do this. We could get rid of this too, I think. We could probably like have some kind of, .add handlers thing where we just look at all the available handlers and register them. That could probably work. Which would make this even easier, right? Then you would literally just need to create a command and a handler for that type, and it would just automatically work. So that's a suitable PR for anyone looking at looking at this. You feel free to submit a PR to the Busylist project. We badly need more active contributors. But this was like a minimalistic, practical example of where reflection can be used to make nicer code. Because, for example, it's not very nice to have to, every time you add a new handler, to have to, add the handler itself, then write it here and add it here. Like it's 3 places where you need to add things to make it work. So if we can get that down to one place, like where you literally just need to create the command and the handler, that would be the best thing, right? That would be very nice to work with. And I mean that's how controllers work, right? That's how they work. You just create them and they work. You don't need to bother about registering them. And I think that's about it for the things that I wanted to talk about. So now would be an excellent time with questions. We still have a few some minutes left for that.
The last, sorry, okay, let me get to the question. So now we are actually manually adding the handlers to the services, right? To register them basically. So
Yeah.
this is basically a hard coding. So what you're trying to imply is basically if we can also add this automatically through reflection. Basically, if you
Yeah.
get all the command types, and then and if you create handlers for all of these types.
Well, basically, I'm saying instead of like whenever you make a command and a handler, you need to make one of these lines too, right? But you
Yes. Yeah.
could very much just do like services dot, add handlers. We could have had something like that, and we could implement
Okay.
this, right? We have to make this ourselves, of course, right?
Yeah.
So we would just make, I service, service collection extensions, and it would be public static class, and we would make a public static void add handlers, which would take in an I service, actually I service collection. And it has to be this. Something like that. So now that works. And now we just need to, write the code that would do this. But we
Yeah.
don't know the types. Like, I mean, the easiest way to do this, like literally the easiest way, would just be do this, right?
Yeah. Copy
that
paste.
would work. But this doesn't really help the problem. Now we still need to write it. It's just in a different place. So how can we implement this method without doing these lines? Well, what we could do, since we know that services.add transient takes in a type, right? You just need to have a type here.
Yeah.
Or you can have a service type and an implementation type, and that's actually what we want. So we need to get those types, right? So we need to get var service type equals type some. Well, yeah. Let's make it so type. We need to make this, and we need to make
Implementation as well. Yes.
Yeah, we need to do those, and then
we map it here basically.
Yes, so here we would do service type, and here we would do implementation type. Like the goal is to get to this.
Yeah.
So in a loop. So how would we do that?
Yes.
How would we do that? Well, my idea would be something like this. We would actually, the trick is to look at these first, I think. So we would do something like var handlers equals assembly. We could cheat a little bit since do we know that all handlers will be in this assembly? Maybe not. But it's really hard to loop over all types that are globally, right? But we could do type of and we do iHandler. And then here, like now we know what this, we know where this is from. So now we can do assembly dot assembly, and then we can do get types.
Yeah.
And now comes the fun part, right? So now we need to do stuff like this, and then we need to do where, because we need to do t dot is assignable to. So we want to get all classes that are assignable to are they though? They're not really assignable to iHandler, are they? I think they might be assignable to, they're not. I'm not sure this is a thing. I'm not sure this actually works. So we'll need to do something like that, and then we'll just do put a breakpoint here, and we'll look, because I'm not sure handlers will be anything. If we run busylist, we'll very quickly hit this, and we'll do F10, and we can see that handlers is empty.
Yeah.
Because like iHandler, right? So to get around this, we might need to make, because right now, look, they're like this, but we need to know the command to be able to find them. So we might need to add an attribute to make them easier to find. Maybe there's a way to find it anyways, but
I mean, why can't we assume that command is of type interface? It's like an abstract class, right? So we can get the implementations of all of them. Okay, command is record right now.
Yeah, we could find all the commands, but how does that help us? We need to find the handler types too. I suppose if we know that, well, okay, I know what kind of means. So let's do that. Let's try that. So var commands, right, equals, we'll just do type of, god damn it, type of command. And then we'll do, assembly dot get types dot get,
No, we'll get all the commands right now.
yes, so we need to filter them. So we'll just do where t is assignable to is assignable from determines whether an instance of a specified type can be assigned to a variable of the current type. Let's try. I can never remember which one this is, but yeah, let's try that. So we'll just do type of command. This should give us all the commands, I think. So if we run this now, we can jump in here and we'll look at commands, and it's empty as well. We'll also do to array because it's easier to debug, but I think it should be is assignable to. I think that's, oh, we need to stop this. And we need to run it again. I think now command should be, yes. So now we have all the commands, but we also have the generic commands, the real command. So we need to remove that one, but we can do that. That's fine. That's easy to do. We know that one will always be first. Actually, we can't. Sorry. We can't always know that it will be first, so we need some way to remove that. But now that we have those, we can do something like for each var command type in commands, and we can stop this, and we can now move this stuff in here.
Yeah.
And we can say, so we can do the whole make generic type thing again, right? Where we can here pass in command type. So now we've built a handler for each type. So handler, and this is the service type. So we can actually do, service type equals this. I'm kind of a var addict, so I just like doing var. But that is the service type, because that will be the one for each command. We still need to filter out one of them, so we need to do something like dot where t there is base type gets the type which the current, yes. So if we say that where base type equals type of command, that should do it. That should do it.
No, it must not be equal to type of command.
No, it must be. It's the base type. Okay. We're saying that it needs to inherit from this. So if let's just put the breakpoint down here, right, and run that again, and we'll see. It should be fine. Yeah.
Yeah.
There we go. That's what we wanted. So then if we go in here, right, I'll just show this. So we make this type, and it's now iHandler of read command. It's a bit hard to see. I know it's really small and also really hard to read these, but it basically says busylist.handlers.ihandler, and then it's generic over something that is busylist.commands.read command, which is what we wanted. So that's that. Now we need to find. Now we basically once again need to use reflection to find this type, right? Because we found this. Yeah. Now we need to find this, and we could do that too. We var. I mean, this is. We just need to find all the types and filter them down to one. So that should be var. Var implementation type equals type
of service type. No, can we use that every time?
We can actually, you know what we can do? We can just do service type. We can just do service type.assembly because we just need like an access to the assembly. And if the service is declared here, it most with it,
It will be
we can
implemented almost in same assembly. Yeah.
let's do command type because like the command and the handler should probably be in the same assembly. If they are not, you would have to change this around. That's fine. Like we can, like right now we're doing everything in one assembly, so it's fine. But it would be if we started splitting this up, we would need to revisit this code, but that would be okay. Once again, we need to do get types. I think there's a find type, isn't there? No, not here. Okay. Get type though. There's a get type. Now that's of course that's of the assembly itself. That's not what we want. No, they don't have any helper methods for that. Okay, let's just do get types. And then once again, we need to do this stuff where we do .where. Actually, we can do where dot.
So default.
We
Single.
could do we single? No, we don't want single because that single like crashes if it doesn't find anything. Well, and that's why if you don't have a command, you should probably have a handler for it. Otherwise, like, what are you doing? So I guess it's fine with single or default. So we'll do single or default, single t, where t is t must be assignable to. So t is assignable to service type. And that should only give us one result, because we should only have one handler ever, I think. So there we go. So that should give us an implementation type. We can now remove that, and then we can just do... And we've just now implemented that, like the thing that I were talking about that should be possible. Let's make sure that is true. So we come here. What is service type? Service type is read command, and implementation type is read handler. There we go. That's what we wanted. So now, if we remove all this, we remove this breakpoint, we go out here, we go to the program for this, we remove all these as well, just have it like this. If I just run this now, it should still work, right? So if I do 5, yeah, read command. No, wait, whoa, what's this? No command registered handled for command type, commands.command. That sounds weird. Why is this happening? Yeah, that's okay. So this branch probably has some bugs in it, but yeah, I think that actually worked though. The registering thing. It's probably some other stuff that's gone wrong in this branch. Like, yeah, we don't actually have a task repository. We just have the interface here. This one hasn't. I haven't updated this in a long while. But yeah, reflection. This went a little bit off track. Sorry for that. But this extension method here, this shows the power of reflection. It should be noted that like looping through all the types in an assembly, in this case twice, and I mean this is nested even, so we do it here and then we do it again nested here. This is why people say reflection is slow. So normally what you want to do, like it's fine if you do in this case we do it on startup, right? We don't do this every request. We do it once during startup, and then we've done with it. We don't do any more reflection after that. As long as you don't you definitely don't want reflection in your hot loop. And hot loop is like the most used code, like like in a game, for example, your rendering loop or your game update loop that gets called 60 to 100 times per second. You definitely don't want to do reflection in there. But it's fine if you do some reflection like on level change or on game startup and stuff like that. So, and that's what ASP.NET does too, right? And Mapster and AutoMapper and all of these, they use reflection, sure, but they only do it once, and they do it in some kind of startup or initialization step. This is why, for example, it's a thing that I see for beginners with AutoMapper is like they create their map, but then they register the map as transient, meaning that the map gets recalculated every time it's needed. Right, which kind of defeats the whole purpose of having a mapper. It makes it really slow because now you're doing runtime reflection for every single request. And if you're using the mapper at multiple places, which you probably are, you're doing repeated runtime reflection of the exact same reflection. So yeah, keep that in mind. Reflection is slow. It's fine to do it at startup. It's fine to do it at initialization, but try to avoid doing it in any kind of hot loop. So yeah, if there are any other questions, that would be a good time. Otherwise, we're going to call it. No other question. Okay. So thank you for joining me. Remember to vote for nominate topics for the next session. I have no idea when that will be. We're probably going to go to a slightly slower cadence right now, so maybe once a week for now, because yeah, I'm just really busy with being on vacation, chilling out at my granddad's pool and stuff like that. It's just what I do now. But thank you for joining, and goodbye.